All right, welcome back. For those of you who happen to be on the first part, sorry about the mistake. Those of you who are on the second one, we'll just start right at the top again. This topic is about wireless LAN architecture and a little evolution along the way. I've been doing this for about 25 years, so it's been a very large chunk of my life has been involved in this wireless LAN architecture. If you don't know me, here is a little bit about me. I've been doing Wi-Fi for a long time. I put on the WLPC conferences. I have a consulting practice. I go and help people have good Wi-Fi, hopefully make their Wi-Fi better. And you can contact me on LinkedIn or use that little link. So today's topic is about the evolution of Wi-Fi, wireless LAN architectures, and where we started, where we are now, and where we're going to be heading in the future. Well, a long time ago, when I first started, we had standalone access points, and these still work today. The 802.11 protocol has always worked with just a single AP, multiple APs. In fact, just this week, I'm at my daughter's and they needed to get some more coverage and they had a spare AP. So I set up a second AP with the same SSID as the first one. Even though they're not the same brand, same model, same capabilities, you can make an ESSID that's a shared SSID between standalone APs. Yeah, sure, the roam doesn't work as efficiently as when you have better systems, but the protocol allows for roaming between multiple branded APs. It works. Standalone access points work. The problem was, if you wanted to scale, it was very difficult. You had to touch each one individually with manual configuration. Each one was totally self-contained, but it did work, and it was a great place to start. At each of these levels that we'll be talking about, we as an industry learned things, adapted, and improved. I guess that's kind of what evolution's about. We then moved on to controller-based networks. This is where we're worried about the management side and the pain of copy pasting CLI commands into multiples, if not hundreds of access points was kind of a pain. We put a controller in, and the first round of controllers, we thought we were going to have all of the work, all the heavy lifting was going to be in the controller. So we made what we call at the time thin APs, and a thin AP was pretty lightweight. It allowed the cost to be lower, less CPU, less RAM on the access point, and we offloaded just about everything to the controller, even things like probe requests and probe responses. An access point would hear a probe request, bundle it up, send it to the controller. The controller would say, oh, I need to answer this, and send back a probe response, and then the AP would send the probe response. Yeah, we learned in this process, there's some things you want to do at the edge. Probe requests and responses are one of them, but there's a lot of things we learned in this process. We could make a controller do most of the work and have very little at the edge, but we found there was better ways to do things. The next step up was something I call distributed intelligence, meaning we put some more brains back in the access points. We still had either a controller or a protocol, and that's why I put the cloud in here. It really wasn't a cloud. It was more of a protocol that allowed APs to talk to other APs and do some management. The actual management layer might have been up in a cloud, but the day-to-day of the traffic flows, the control planes were handled from AP to AP. This worked. No doubt it was an improvement over many of the other ways of doing a controller only. Some vendors also had a controller in the cloud that acted just like a regular controller, but they would slowly split some of the roles and responsibilities of what an AP would do versus what a controller would do. I've installed lots of these. It works. It worked in fact, some of you might have customers that still use this type of architecture. Then moving on, we moved up a level and said, you know what, we can put more up in the cloud. And so we designed systems where the cloud itself was the bulk of the controller functions, the management functions, and then we only left data plane down low. This allowed us to scale. We could make a profile, add a remote site, and just ship the equipment. They wake up, they phone into the cloud, they get their configurations, and they start working. This also changed our business model somewhat. And people started offering a subscription model where we could put more into the OpEx and maybe less in the CapEx. But we've got a slide later on. We're going to talk about the business model changes as well. Today, a lot of you are running something that's more of a hybrid model where you could use a cloud for all management, or some of you and some of your customers still require an on-premise device, a physical controller device. Different vendors offer these where you can either choose to have a hardware controller locally, a software controller locally that runs on a VM on your hardware in your data center, or a cloud-based controller. Any of them work. And as we're moving forward, we're getting more and more intelligence at the edge, not just to do Wi-Fi things, but to actually add some AI at the edge. Just last week, we had announcements that new Wi-Fi chipsets are coming out, and they have built in, even the low end, some AI features trying to push more and more intelligence to the edge. So we're kind of at this point today with most vendors, but let's talk about where we're going in the future. More and more AI. And I hate hearing AI all the time. It's everywhere, but it is everywhere, and it is going to be influential in our future. We're moving to a point where the AI itself, the operations use AI to solve their own issues, even before the customers might be aware. This is a little concerning to those of us who work in this business. Is our job going to be gone? My concern isn't whether or not our job is going to be gone, it's whether or not everyone can learn to use AI properly to help you in your job. My other concern is if we have AI fix the easy things. Now, I get called out all the time around the world to go and fix people's broken Wi-Fi. Sometimes it's just tuning, sometimes it's trying to fix things. The entire 7-signal model is based on trying to improve Wi-Fi to make it work better. AI is there today trying to make these improvements, but you need visibility to see what's wrong. Sometimes that means you need to be on site, either me personally or a 7-signal sensor on site to hear what's going on in the air. But AI is moving forward in the ability to listen to what's wrong and fix it. Again, my concern for us as a community isn't that AI is going to take our jobs. It's that where will people learn when the AI fixes the easy things? Where will you get the practice to know and to recognize those easy problems if they're already solved? And the ones that AI can't solve, the hard ones, no one's ever had practice to get there. So just a word of warning as we're moving forward let's keep using our brains and with junior engineers to work on the lower level problems so they get some practice. Just don't dump everything off on the AI. Anyway, we're just doing a little quick evolution of where we're going. The future is where they're fully autonomous. They learn what the problem is, they heal themselves, and this is kind of the holy grail where we'd like to be. I don't think we're there now. In fact, I'm sure we're not there now. I still make a living fixing Wi-Fi, but the challenges that I go to fix, they're still there. The fundamentals haven't changed. And if you understand the fundamentals of how Wi-Fi works, it still will hold you in good stead to solve problems. The problems are just getting a little more complex, partly because Wi-Fi has gone from being a nice to have when we had standalone APs to today, it's 90% of most traffic in most companies is going over Wi-Fi. That's the ingress, egress point for the network traffic. So we still have to use Wi-Fi. So that was a quick overview of the architectures. But what I'd really like to talk about today, actually, let me do the key takeaways, then I'll get to the main topic, is as a review, we started out standalone, we went centralized, we went distributed, we added more intelligence, and hopefully in the future, we'll have better autonomy is where we're headed. All of that said, we're in the midst of this other change. This is a big change. This is a change in the actual business models of how vendors, customers, end users, how they interact with the entire infrastructure build. We started with you would buy something, kind of like you would buy a car. You go to the dealership, you might have to get a car loan or you could pay cash. It was your car. If it broke down, you paid for it, you fixed it. it was all yours. And this was put in the category of CapEx. There was a capital expenditure up front, you owned it, and depending on which vendor you're with, you might pay, I don't know, 12% or 18% a year for ongoing maintenance to move forward. That model is still available today. Some vendors still use that model, but more and more vendors are moving into this OpEx model where there's a subscription price. Actually, there's some vendors who kind of merge both the CapEx and the OpEx. They want you to buy it, then they want you to lease it on top of that. But this is more of a cloud-based system where you have a subscription and you just pay on an annual basis for your hardware and your software. Where we're moving to, and this isn't all vendors, there's some vendors who are leading in this space, but other vendors are trying to catch up, is more of a network as a service solution. You buy the entire service as a plan, and then you just pay to have your network work. Any one of these is available to you today. OpEx, CapEx, NAS models, they're all available. And you need to do your research to find which of these fits in your specific business requirements. Some people are still old school. They like to buy and own their own gear. Some love the subscription model because from a CFO standpoint, it's easier to keep a specific annual amount and just know that's going to exist. I have a son who leases cars. I can't imagine leasing a car, but he just says, I'm going to be paying a car payment anyway, so why not just lease it? So there are people who just live in that OpEx model because it fits their financial goals. Others are moving to the NAS model where they can continue just to have a fixed amount and it covers all the costs of running the entire network. But going back to the fundamentals, I mentioned this earlier. The fundamentals of how Wi-Fi works haven't changed in 25 years. 802.11 is still 802.11. Sure, we add more and more new amendments and we get faster and better and more stable and all these good things, but the core is still the core. And it doesn't matter which of these architectures you're designing for, we still have to meet the same requirements that we've always met. And they start with this. This is something that a association, the Wireless LAN Association, put together, and I wholeheartedly agree with it. We go through this phase of define your needs, design to meet those needs, deploy it, and then ongoing diagnose it to make sure it's meeting those needs. And you have to go through this cycle multiple times. Sometimes the definition will change in the future. You have, new devices come out with 6 gig. So now I might have to cycle back through. And so this isn't just a one and done. We do this over and over again. Since wireless is the primary access layer for most people, we need to put our time in here. Design matters. Most of the time I go and fix Wi-Fi, it's not because the hardware doesn't work, not because some individual vendor's device broke. It usually comes down to a design issue. Sometimes it's the configuration that was supposed to be done that wasn't done. And all designs should start with requirements. Well, what requirements? It's not about AP placement. That's kind of the end. What we need to start with is what requirements should we do? Well, first up, what are the business requirements? Who's using it? What areas need it? What applications will be running today and what's in the future? And what devices specifically are they using? And how do we design to make sure those devices run those apps in the areas they need as efficiently as possible? So first, collect the data about what the business use case is. Then we're going to translate that, and this is your role in the engineering of a Wi-Fi system, to take the business requirements and turn those into technical requirements that say things like, well, what's the redundancy need we have? What do we need for RSSI primary and secondary? What are our security concerns? How are we going to do the things that the business wanted? So we listen to our customers, find out what they want, ask a lot of questions. That definition side should take a lot of time. It's not, oh yeah, I want Wi-Fi that works. When my customers say that, I usually slow down and go, okay, let's now define, what did you mean you want Wi-Fi that just works? Sometimes they take literally hours to work through enough questions. I feel like a 2-year-old. Why? Why? Well, I want it to just work. Well, what do you mean just work? Well, I want that. And then you have to ask more and more questions to find out what they need so that you can turn them into a technical requirement. Because going into the design phase, we need to know exactly what we're designing for. So we're going to take the business requirements, turn them into technical requirements, and then turn them into specific RF requirements. If you don't have these requirements, it's really hard to tell. Let's just back off. I'm going to blank the screen just for a second so you can look at me. If you don't know your requirements, how can you possibly meet them? Truly. So if this was a cabling webinar and we're talking about cabling, we would tell our cable low voltage electricians coming in, we want 10 gig to these switches. We need 1 gig to the desktops. We need APs connected with this type of cable carrying this type of PoE. And then we would have them validate the cable after they install it to prove it gives them what they want. I don't pay my cable contractors until after they give me back a proof of validation that it did the thing that I'm paying them for. When it comes to Wi-Fi, we need those same type of requirements. We're not going to say Cat 7. We're going to say we need primary RSSI, secondary RSSI, some SNR requirement. And the bugaboo that gets a lot of people is you need to define what is co-channel contention for your area and what are you willing to accept, and then design to meet those specific requirements. We also have client density requirements and some silly little things like channel widths. A lot of times we have people who ask for things that probably aren't a good thing to ask for, partially because they don't know any better. A lot of them don't know that when you go to wider channels, you're increasing the chances of having co-channel interference. So simple rule of thumb for channel width, go to the widest channel you can until you can't. How do you know you can't? Well, when you get co-channel interference. Because I would rather have two 20 meg channels, each with their own lesser bandwidth, than two APs on the same 40 megahertz channel contending the entire time. My net throughput goes up when I lower that contention. So channel widths are a part of the equation that goes into play with co-channel contention. We have to meet primary coverage. That's just the minimum. That's the ante to get in and play in this game. It allows us to meet coverage requirements where we need it. In addition, we have secondary coverage, and secondary coverage is what allows roaming to happen as smoothly as possible. So you need both primary and secondary, and add some reliability and a little bit of redundancy. I don't see secondary coverage as a great redundancy because it can be by the same AP with two radios on the same frequency. Like we have radios now, we can get a 1, 2, 4, and 2 5s, or a 2, 4, 5, and 6. And how we configure those, it might not give me a redundancy if an AP goes down, but it does add to reliability and better continuity in roaming. How do you define co-channel contention? Adding APs increases co-channel contention. For over 20 years now, one of my most effective methods of fixing people's Wi-Fi is turning off radios because they have too much Wi-Fi in the air and there's too much contention. Years ago, probably 20 years ago, if you see any of my graphics that are pink and green, you'll know that purple and green, they're at least 20 years old. But this want, don't care is a good way of looking at contention. When you have two APs on the same channel, depending on how close they are together, what you want is the area that meets your requirement, down to neg 67, neg 75, 64, 63, whatever your number is, that's the first line. And then on the other side, the green side, if where I'm contending with the same two APs on the same channel, but it's below something like neg 85, I don't care anymore because it's not going to bother that other access point. So the want is the part you want. The don't care is it's below the level. So yes, it's sensible, but it's not going to actually make any substantial difference. But the really important part is this don't want in the middle. I don't want to have two APs that are contending to each other at a level where the client that's in between is going to have to wait for both APs. So define your co-channel contention with this kind of method. Then we need to come back and look at capacity. I said here, designed for peak usage. Yeah, you could do that. Some stores have had me come in and they've designed for peak usage. What about on, the Black Friday, the day after Thanksgiving, and the place is full of people? Should we design for 500 people in the same area in front of the store? It only happens once a year. So maybe that's not the peak you're going to design for, but the normal everyday kind of peak. Different areas require different design densities. And first, design for coverage. After you've designed for coverage, come back in and see what you need to add to give you the capacity need. And as you're adding, be very careful that you're not adding too much that's going to add to co-channel contention, because two APs on the same channel have the capacity of one. So just adding another AP doesn't add capacity by itself. Now, this environmental consideration, I got this little picture of, oh yeah, save the environment. That's a little bit of it. There is a little bit we'd like to have power constraints and access points we're getting from vendors today have the ability to turn off some spatial streams to lower the power consumption, or in the evening when people aren't using them, turn it down even more. But I'm thinking more about the environment of the room where you're doing this. What are the ceiling heights? Where can I put APs? What are the materials around me? You find this by going physically on site to see these. And when you go on site, you might want to do some attenuation measurements on a wall. You'll need to take with you something that makes RF, something that measures RF, and then you go on both sides of the wall and you measure the thing that made RF on two sides and see what the difference is. I would strongly recommend the thing that measures RF has the ability to lock on a specific frequency. If I lock on a frequency, I will see all the beacons 10 times per second. I'll get lots of good data points. If the device I'm using is just a phone and it's scanning lots of channels, well, at that point, I might have to stand for 4, 5, 10 seconds before I get enough data from that one channel, versus, hey, the ability to fix it on a specific frequency, then I get a lot of data very quickly and I can get a better number. Now, all of this information is going to go into your design tool of choice, and you will design to meet all of those requirements. One issue here is also, what's the spectrum where you are? This has to do with your geography. It has to do with DFS. And I've been following some discussions on some Slack channels and on LinkedIn about DFS. Most of the time you can use DFS channels. Don't be afraid of DFS. Use DFS until you can't. You know when you can't, when you get log files that say, I changed because it was on this channel. If you get enough of those, then just remove that one DFS channel from your channel plan. But use them. Don't waste all of that spectrum that we have. I lean towards 5. I lean towards 6, depending on your geography. You may or not have the full 6 gigahertz spectrum, but even in Europe where you have less, it's still better than, I mean, it's as much as you had in 5 gig, just double again. So use those spectrums as you can. I know that today, with the speeds that we're running, you might not necessarily have to limit your SSIDs, but it's a good habit to get into. You can use other things like user identity and VLANs to segment better. 15, 20 SSIDs, just because you can doesn't mean you should. So control that strategy as well. So just to recap here, gather the requirements, model in your tool, validate the coverage, try to optimize SNR as well as you can, reduce contention. That should be that's like my #1 attempted goal, because I know that if I have two APs on the same channel that overlap, I only receive the capacity of one AP. So that second AP costs me money for install, costs me money for the AP, costs the cabling cost, switch port cost, AP licensing cost, and I didn't get any extra capacity. So the contention is the one you can use. And then adjust your network, your design to meet those capacities. And when you're done, validate it. I started with the blank screen a little while ago, talking about, cables. You pay the cable contractor when he proves the cable works. In the Wi-Fi world, you prove the Wi-Fi works by doing a validation and tuning, and you fix it before you hand off to your customer. Fernay and I have been working on some checklists. I'll show you a couple here just as we finish up. As you go through, you should have a checklist for your design. What are all those things that you need to collect data from the business model, the technical requirements, the RF requirements, the on-site documentation, where could you place APs, where's the cable plant, all of those things. And also have a checklist in there for after you install, what's the acceptance criteria? What will say this Wi-Fi is now good enough to turn over to my customer? We have developed these checklists where you can go through and say, does it meet my requirements? The green ones are the ones that have requirements that you change. You can change this. It's just an Excel doc. You can change them to be whatever you want it to be for the profile you're after. But I like using checklists because they're very fast ways to go back and use it. We have one for extended, as well as sometimes there's stuff you can't hear over the air that you might need to go get into a controller, perhaps into a switch, and make sure these things are also happening. If you check off the things that work, more than likely your Wi-Fi is going to work the way you want it to work. Requirements drive your design. Coverage matters, but capacity matters as well. And validate everything you do. Networks should perform as they were designed. Now, I have to admit, I make a living because people don't do this. I'm here telling you that you can make your networks better by going through these steps and making sure that your network does what it's supposed to do, know your requirements, meet the requirements, and you could be happy. I'm just going to leave this up. I'm not going to talk through it. Just some top 10 things. Look at this. It's in the slide deck you're going to get. And on to any questions.
All right. That was great, Keith. Thank you so much. There are a few questions. I'm actually going to start by asking a question of my own because I run into this a lot. And that is, I mean, people are bringing whatever they want, or they are allowed to choose whatever they want with regards to a laptop computer. And so what we're seeing at Seven Signal is we're going into environments where it's almost 50% MacBook, 50% Windows, and they behave so differently on Wi-Fi networks. Do you have any recommendations with regards to, how you fulfill the requirement of making sure that everybody roams properly when you have such diverse environments? Or do you make a rule that says, look, we can't do that? What's your opinion?
That's part of the discussion on the business requirement side. I talk with the customers. If they have a predominance of Macs, you can design networks that help Macs roam better. Because Macs they've published, at least Apple has published, not all of their decision matrix that goes into when I should roam, but they published a lot of them. One of the big ones is they need to get a signal to drop below a certain threshold in order to start looking. So one of the techniques we've used in schools or hospitals where we know they have a predominance of Macs is we make sure that when the client leaves one classroom and walks into the hallway, they roam. That means no APs in the hallways, poor coverage in hallways, because we want to trigger that roam. So there's ways to get around that. But the downside is we've done that in a whole lot of schools, and it works great for all Macs. Chromebooks can do the same thing, even though they don't use the Macs algorithm. When you force them to roam every time they leave a room, they roam back in when they go to the next room, just kind of how it works. And then one of my school districts added phones and added voice over IP. And when their teachers would take a phone call, they would take it and take their phone and walk into the hallway to make their call, where we had really, really bad Wi-Fi.
Right.
And so sometimes it's difficult to meet all the requirements. We designed it, we made it work so that clients would roam cleanly. There was no more sticky clients. They work great in the classrooms and terrible in the halls because of that Mac difference. It didn't work for voice. And then we have the opposite is true when we have hospitals where they need to roam in the hallways. And the problem would be if you put an AP in a hallway, the client doesn't roam whenever they're in the hall, and a nurse goes back and forth all day with no problem. They step into one room and they drop the call every time they leave the hallway because APs in hallways they light up the hall great, but there's a really hard break off when you leave the room. So
Mhm.
even though it seems like it's the right choice to put APs in hallways and hospitals, it's actually not. What we'd like is to have APs in rooms. And so as you're walking down the hall, there's more roams that happen naturally. So yes, you can design around that. But between Windows and Macs, you're right, they roam differently. Um,
Hard to
and
design.
yeah, it's you designed to meet that. It's just part of the requirement.
Yeah. Now, speaking of requirements, I just have a follow-up question. You had talked earlier in the discussion about, business people who say, "Hey, I just want it to work," or or I want it to go fast. You are dealing with people who are not Wi-Fi people. They are business people. And I mean, what are some of the top questions that you ask? Do you say, what kinds of devices do you have? Or what kind of applications do you use? What are those questions that kind of get the conversation going so that you, as an expert, can get the information you need to proceed?
Uh, just like you said, what are your devices?
Hmm.
What are your areas? And
Okay.
areas have different requirements. What are your applications you're running? And from those, we can find out which device is most important. Now, we used to maybe 10 years ago push really hard, least capable, most important device.
Yes.
And if we
Yep.
designed for the least capable device, it worked. I've since I rarely use that technique anymore.
Mhm.
Um, it's not because it's least capable, it's just what's most important and make sure the most important ones work. Uh, we used to try to find, oh, they're all important, but this is the least. So let's make the least work, then the other ones will work. That works, but trying to track down what's least and then they go buy a new one and they're like, oh, let's buy a least one. No, we just buy the best you can. We'll try to make it work. So it's asking what
Awesome.
are their devices, what are their applications, where do they go, and a little, sometimes it's when. Um,
Okay.
Ed-use load up rooms, churches, hospitals have shift time changes. So the when question comes into play as well.
Okay. Awesome. Okay. One question here is about PoE and the design considerations and the costs associated with PoE plus and new
Plus, plus, plus.
and plus plus. Exactly. I mean, this is expensive stuff. I mean, depending upon what they're trying to accomplish, and if they want to go to 6E and they want to use all three bands, I mean, that's something that you're finding you have to kind of sniff out also.
Uh, definitely. It's kind of a chicken egg problem between switches and access points.
Yeah.
Sometimes, and rarely do those two life cycles coincide right when you want them to coincide.
Mhm.
People buy switches and say they're on a 7 or a 10 year life cycle. They buy access points and they might be on a 3, 5, 7 year cycle.
Mhm.
Wi-Fi changes obviously faster than the switch world does. Sometimes, if you have budget money for access points, you might have to live with the fact that I'm not going to have enough PoE. So if I don't have PoE++, but I've just bought a brand new Wi-Fi 7 or Wi-Fi 6 EAP that requires plus plus,
Yeah.
they've been all the vendors design their APs that if they don't get the power they need, they throttle back something. They turn off radio change. They might even turn off an entire radio, but they work. So if
Mhm.
you're in this is a layer 8 issue. It has to do with budgeting and timing and when happens. If you can, it's best to put out new switches and new APs. That's the best. But we all don't
Yeah.
have that option.
Right.
If you do have budget money this year for APs, don't buy an AP because don't stop buying a new AP just because you don't have PoE++ yet. Put the AP in, design the AP, but realize in your design, you won't be having all the spatial streams you might need. You might have a radio turned off until you catch up with the switch. So this is a budgetary issue. Some save their budget for a year and try to accomplish it at the same time. Some say, let's just do one building at a time and we'll do both wired and wireless together and kind of keep them on track. So any of those methods work, but you will need better. You may even, and this is scary, it happens, cable plant has a lifespan.
Yeah.
We don't like talking about it, we don't like thinking about it. We kind of want to think it's forever. We put in
Mhm.
cable, we're like, yeah, it's going to last forever. It doesn't. There's sometimes you have cable plant that just isn't capable of carrying what you need.
Wow.
Either they ran too long, they used Cat 3 and you pushed Cat 3 to its limit and it can't carry any more PoE. Um, you might have put in Cat 5 and it's at its limit. So one other cycle is also looking at the cable plant and seeing what you can do there.
Interesting. I think that's probably overlooked. You don't think about the fact that, wow, do we have to run new cable? This cable's, it's been sitting in the walls for 15, 20 years, right?
And sometimes 20-year cable does fine.
Yeah.
It's just one of those things you have to look at.
Yeah.
Um, another just a quick trick. What I like to do when I'm doing a design, I'll go and find out where their cable drops are today. One, I do not like rip and replace.
Mhm.
If you're going to be putting in a new AP, design for that AP. It might have to be in a different location. It might require a new cable.
Yeah.
But putting an AP, a new AP in an old spot, almost guarantees it's not going to do what you want it to do.
Yeah.
So a trick is you take your floor plan and where your current APs are, and you find out where your, if you have a biscuit jack with an extra cable length, or did you design for 80 meters and you left 20 left over, or is there a service loop up in the ceiling? Find out what the cable plant looks like. And then I draw little circles. Say I have a 5 meter service loop at each AP. I'll put a little 5 meter circle around each of those locations. So when I'm designing for the next rev, I'll know if I can stay inside that target, I have a cheap cable plant to go there. And then it
Interesting.
allows me to maybe get, 3/4, 80% of my new AP locations covered with an old cable and only have to pull the new cable to very few of them.
Wow, interesting. Now, speaking of new APs, somebody was just asked, obviously they're going through an evaluation process with, Wi-Fi 6E coming out. There's a lot of evaluation taking place today with what do I upgrade to since I want to take advantage of 6 GHz. Somebody was asking about Ubiquity and whether Ubiquity has kind of reached a point where, in terms of its reputation and its for quality, that it actually can be reliable in the enterprise. Any thoughts on that?
I've done some very, very large installs with thousands of APs with Ubiquity, and it
Uh-huh.
works.
Good.
Some
Okay.
caveats.
Like what?
Some of the things in Ubiquity's UI aren't terribly friendly for professionals who do this.
Okay.
Like just last week in Prague, Tom Hildenbrand from Ubiquity announced they're finally, in the next rev, going to have an AP name in the beacon. Yay! From a troubleshooting standpoint, that makes all the difference that I
I
don't
know.
have to go into the controller to find which AP and do a reverse lookup on MAC address. Having it just in the beacon is going to make it helpful. So Ubiquity's come a long way. They're stepping into the enterprise space. Their RRM is still kind of a little early.
Okay.
It doesn't work as well, but depending on your design, you can use your design tool to set those and then just hard code them back in on the Ubiquity side.
That's right.
But Tom also announced that Ubiquity has a whole RRM algorithm that will be released soon. So let's see. But from a hardware standpoint, they've improved. They have new APs with directional antennas built in, even ones that go wide or narrow based on software control.
Okay. Good. Good. All right. Let's see if we have any other questions here. Last one is just, you've been doing this for a long time. Let me try to phrase this properly. And it
Yeah, yeah,
sounds
right
like,
here.
yeah, white hair. Yep, got it. Got a little myself. And it sounds like, the kinds of questions that you ask about how to perform a great design, you know, 15 years ago were kind of the same that we have today. We just got to remember to ask them. But you were also talking about the future and with AI coming out, any new questions that are coming to the surface with regards to requirements and considerations? Do you have to start asking new questions and different questions with some of what's happening in the future?
I think part of that goes back to that PoE and that cable
Mm, okay.
plant.
Yeah.
If we're going to be using AI at the edge, which is a good place to keep it, we have an access point. It has a big CPU. It has some extra cycles at times to use We can do more thinking closer to the edge. That just reinforces the fact we need faster switch ports,
Yeah.
more PoE, because there'll be more traffic coming from the edge. And one add-on to that is we used to think of our cable plant was, our core, our edge switches, and then our access points. Access points are aggregators of data. 15, 20, 30 people are filling the pipe, and then the AP is now connected to a switch. It used to be that those edge switches were our aggregators. Now our access points are aggregating multiple users. 90% of our network traffic is coming over the Wi-Fi, coming through an access point. That cable from the access point to the switch, that edge switch now has to have a lot more horsepower because let's say half of its switch ports are used for APs. Every one of those is full. So now we have to have 10 gig minimum uplinks from the switches because they're an aggregator of aggregators. And we don't always think about a switch as that. We called them edge switches thinking they were an aggregator. Now they're actually aggregating pre-aggregated data, if that makes sense. Sorry, I used the word aggregate too many times.
No, it's great. It's a good word. A lot of syllables, agreed, but good word nonetheless. All right, guys. Hey, awesome stuff, Keith. I learned a lot. I love this, just having the opportunity to interact with you on this stuff. I always learn something, and I know our audience does as well. Hey, I'm going to transition right into, that time, 7 minutes with 7signal, where we take a small feature inside 7signal, unpack it, and show you how it can have huge value. So guess what, guys? We were talking a little bit about AI today. And so I'm going to show you a little bit of what 7signal is doing with AI. You should be able to see my screen. Give me the thumbs up, Keith, if you can. All right. Guys, I'm in Claude. Claude is just one of the many kind of AI clients that are out there that people are using to interact with ChatGPT, Copilot, Gemini, Claude from Anthropic. We're using a lot of Claude here at 7signal. And what we've done at 7signal is that we have built what's called an MCP server, Model Context Protocol, which basically is a wrapper around our API, allowing it to then interact with a client, with a chat client, an AI client, just like what you see right here. So this screen is going to look familiar to you depending upon which one you use. But the idea here is that we have created this MCP connector, and we have actually connected the 7signal API. As you can see on the screen, we've connected it to Claude. What that now means is that I can use Claude in order to interact with the 7signal API in your location. So think about this, guys. In the future, we don't necessarily think that, okay, everybody's going to be in our system. Oh, I'm going to go into 7signal. I'm going to look up what's going on. Oh, now I got to go over to Cisco. Oh, now I got to go over to Aruba. Oh, now I got to go over to this system. Now let's take a look in ServiceNow. All of these different systems, if they have MCP servers, then they can all commingle. They can all, in a sense, collaborate with one another in order to get you the answer. Imagine going into Claude and saying, what's wrong with my network? It gathers data from 7signal, maybe from Thousand Eyes, maybe from Splunk. It then correlates all of the data to come up with a solution. And then because there's an MCP server integrated with Cisco DNAC, it now makes those automatic changes proactively in the manner that Keith was just talking about. Let me just show you an example of what I mean here. So for example, I can just come in here and say, can you find the Eric Kamuli, that's me, device? Okay. And what it's going to do is it's actually going to go out and it's going to take a look. It's going to integrate with our API because of the MCP connector. And so it's going to ruminate just like it's saying right here, right now. And sometimes it could be a little slow, so bear with me here. I'll search for the Eric Kamuli device in your 7signal environment. It's going to then do the little agent call right here. It's going to search and it's going to find it. And when it finds it, it's going to kind of print out everything that it knows about it. Check this out. Okay, this is the kind of device it is. This is the adapter that it has. It's running, it's working, it's great. You know what? Let's do a performance analysis. You know what? Let's say, how is Wi-Fi performance? Okay, and let's see what it says. It's going to go out and it knows that it can get all of these juicy metrics from 7signal, like throughput speeds and congestion metrics and all sorts of things that are taking place on the device. and it's going to go out and it's going to take that information and then turn it into a format where it can actually, communicate to you in a way that you can understand. Now imagine this, guys, while this is working. Imagine this. So you have 7 signal sensors like all over the place, all over the world. Before anybody even walks into the office for the grand opening, I can just come to Claude or whatever my client is, and I can say, hey, tell me about the performance in the conference room or in the auditorium today before the meeting starts. Don't you wish Zuckerberg had this when he was doing his thing a few weeks ago on his little Meta glasses or whatever? He can actually ask Anthropic or ask Meta, hey, what is the performance in that room before I even walk into it? And it would give him a full analysis, just like what you're seeing on the screen. Is this hot? Is this hot to trot? And you can even say, can you put this into a report? And because Anthropic and Claude are kind of good at drawing up reports and doing cool stuff like that, it will actually come up with kind of like a performance summary for this device. I can do it for a service area. I can do it for a building. I can do it for a location, for a clinic, whatever I want. And look at the screen, guys. It's going to go out and it's going to do it a little executive summary for the CEO of the organization or whoever it is. And you can then take this off and send it to whoever needs to know. Guys, this is hot to trot. And this is where 7Signal is heading. Again, we want to be able to have our data available to other systems. We're coming out with a new ServiceNow integration in the near future where this kind of data can integrate and then tickets can automatically be created and problems can be solved before anybody even knows, before anybody has to pick up the phone. Whew, pretty cool stuff. So that's what I wanted to share with you guys today. And Keith, thank you so much for this. This was awesome. And I just want to say, as parting remarks, while you and me, we can't see or hear can't see or hear Wi-Fi, but 7Signal can. And I just want to say thank you to all of you today. And until next time.